Hey everybody, thanks for watching this video that I am recording from my garage. Maybe a little bouncy and shaky on the video feed. I did my best to put together something that looks okay, and this is as good as I could do. I wanted to say I enjoyed my first week in Hays. You guys really impressed me. I think we're going to really work well together if we, again, put in that effort and, just give me a little bit of your trust, knowing that that I am an expert in mathematics and that I will lead you down a good path, a worthwhile path. So, with that in mind, let's move on to today's task. The first thing I want to do is remind you of a few things that we did last time. Understand and explain the multiplication algorithm. I don't think we did that fully yet, so we're going to keep working on it. We did define algorithm. Remember, it's just a set of steps. This multiplication thing is an algorithm if you treat it that way. Multiply the 8 by the 6, and that's 48. Put the 8 there, and carry the 4 over to here, and then multiply the 8 by the. Now, if we're purely algorithmic thinkers, we're going to multiply 8 by 5, even though that's not a 5. Remember, it's a 50. We're going to multiply the 8 by the 5 and get 40, and we're going to put the we're going to add the 4 on. 44 is what we get. That's just, like I said, it's an algorithm. It's a set of steps, and it is devoid of meaning. We don't know what all this is. Why do I multiply the 8 by the 5, or even why do I multiply the 8 by the 50? What purpose is there in it? Why do I have to do that? Why isn't there some other way of multiplying that I don't do that? Okay, so like I told you, what I like about math is that you can show absolutely that's what you have to do, and this is why you have to do it, right? And we're going to concentrate on that word, why. We're going to ask the question, why? Why does that work? Why is that true? Why do we do that? Okay, so anytime you have a question of why do we do that, please ask, because it wasn't encouraged in my math education, which made it difficult. It made it hard to understand. So just ask anytime. Create a thorough definition of area. We definitely did that. In fact, let's just jump into what is area. Let me just grab a pen here. Area question mark. What is it precisely? What is it thoroughly? Exactly what is area? And if you remember from last time, area is the number of squares. Excuse my sloppy handwriting. Squares that fit. Okay? If I can figure out how many squares fit inside this rectangle, I have the area. That's what the area is, right? That's what it means. So what is the area of this thing? Well, we've got to know some stuff, right? So if this was 7 and this were 5, right? We learned that we should be a little maybe more specific, right? So this maybe is inches and this is inches. All right, so that means that there's enough room, if I can draw this okay, there's enough room for 7 inches along the horizontal here, and for 5 inches along the vertical, right? And so what we have here is something that is 1 inch by 1 inch. Now that does not look like a square, which we talked about in class, but we're going to have to just make pretend that it is a square. It's 1 inch on one side and then an inch on the other side. So how many of these squares will fit inside the rectangle? This starts to explain a lot of things. Why is area length times width, the base times height, or however you want to say it? Well, because it's just the fastest way to count the number of squares that fit inside this rectangle. Because 7 of those bad boys can fit along here. 1, 2, 3, 4, 5, 6, and 7 squares. Well, okay, 7 squares in that row. How many rows can I fit? I can fit 5 rows. So the fastest way to count the squares would be to just multiply 7 by 5. It's faster than just literally counting every single one of them. And I can't imagine a faster way. So it's just efficient. So what do we have? We have 35 of what? That's how we started talking about area. What do we have 35 of? We have 35 squares. 35 squares. Well, we don't usually write squares because we want to specify what kind of squares. These kinds of squares in particular are inch squares. Inches squared. So there we have it. A quick little review of what we did last time. Area is the number of squares. It just kind of depends on what kind of squares they are, and that's it. Beyond that, what we did was to make sense of this multiplication algorithm, right? 56 by 38. When we multiply that together, why do we do all the steps in the algorithm that we do? And to make that, to tie that together with area, we said, well, 56 by 38, well, we could think of that as like the area of this rectangle, 56 times 38. And then we said, that's great, but I don't know what 56 times 38 is off the top of my head. So we broke it down, made it easier. We put a little mark about there, just kind of guessing. That's 50, and this is 56 still along this side. We put a little mark here, call that 30, and this 8, right? So then what do we have? We have, we'll grab a different color. Sorry, I'm so quiet. It takes a lot of concentration to draw a horrible straight line. So what do we have? We have 1, 2, 3, 4 new rectangles inside the smaller rectangle. If we can find the area of all 4 of these little rectangles, we then add them together, we find the area of the large rectangle. Right? And so we talked about how, okay, what's the area of this guy? Well, it's 6 by 30, that's 180. This guy down here is 6 by 8, so that's 48. This one is 50 by 30, so that's 1500. And this one is 50 by 8, that's 400. And because we broke them up the way that we did, it's a little easier to do that multiplication, much easier than just doing 56 by 38 in your head. And so now all we have to do is add up all these areas, and we'll have the area of the whole thing. And if you'll notice, it's exactly what we do in this multiplication algorithm, but we've made sense of all those steps. We get why we're doing them. Now we know why we multiply 8 by 5, or truly 8 by 50. Well, because that's that little sliver of area right there. We need to know what that area is. So we multiply 8 by 50. That's why we do it. And we're answering the question of why. Why do we do these things? So we add it all together. 180, 400, 48. Add all those together, get an 8. 8 plus 4, that's 12. And we're adding up the tens right now, and we got so many tens that we actually crossed over into some hundreds. When you get 12 tens, right? And really what we're doing is 80 plus 40 is 120, right? But, well, 120, well, that's an extra 100 that should go with the hundreds. So 100 plus 500 plus 100 plus 400, right? So that's 9, 10, 11. So it's 1100. That's 1,100. So we have 100 and 1,000. So 1,000 plus 1,000 is 2,000. There we have it. We've figured out what 56 times 38 is by breaking it down and looking at it as an area, and by looking at it as area, we've made a lot more sense of the algorithm than probably was made for you the first time you learned this. So let's move on to a new example. I want you guys to give this a try yourselves. You just saw me work out an example. I want you to get out a piece of paper or something, maybe pause the video, and work out this next one with me. All right. Well, I thought I had a bunch of rectangles. Let me draw another rectangle. All right, so we're going to use this area model to just do another multiplication problem. But you're going to, when you use your hands and you write it down, it is very helpful. It's much more meaningful. Okay, so let's get out your pen and paper, or whatever you have to write with, whatever it is. We'll multiply, totally making up 47 times 86. It's going to be a big one. Right? We're not going to, at this moment, multiply it with the algorithm. We're going to multiply it using area so that we get why we're doing all these things. Right? So this side's going to be, well, make this longer side the 86. How about that? And rather than just write 86, we'll make a little mark here and say this is 80 and this is 6. Then we'll come along here with 47. Make sure you're writing this along with me. That's 40 and that's 7. So now we'll just break it into those little rectangles. And here we go. So, and at this time, let's try and maybe tie the two things together. We know the multiplication algorithm. Let's see where it takes place in our area model. Right, so the first thing you would do is multiply the 6 by the 7. Well, why is that? Because if we look at it as area, that's the area of this little rectangle, which we need to find the total area. So 6 by 7 is 42. Okay. The next step, you see I use quotes when I want to mock things, like this multiplication algorithm. 6 by 4, well, we see that's not 6 by 4, it's 6 by 40. Right, multiplying 6 by 40. Why do we do that? Because that's the area of this guy right here. So we are going to multiply 6 by 40. That's as easy as multiplying by 6 by 4 and then multiplying by 10. So we get 240. All right. The next step would be 8 by 7. Why are we multiplying 8 by 7? Oh, it's really 80 by 7 because that's the area of this little rectangle, right? When we're paying attention to these place values, multiplying 80 by 7 is necessary in order to find the area of this little rectangle here. So 80 by 7 is 560. And the last step of the algorithm would be to multiply 8 by 4, or really 80 by 40. Why do you do that? Because that's the area of this very large rectangle here. We need that area in order to add up all the areas and get the total area. So 80 by 40 is going to be 3,200, right? And so we add them all together. 3,200, 240, 560, and 42. We add up all the ones and we get 2 ones. We add up all of the tens and we get 14 tens. That's enough for 4 tens and 100. We add up all the hundreds. We get 200, 300, 400, 500, 1,000. That would be 1,000. So there's actually 0 hundreds, but there was just enough to make a single 1,000. And we add up the thousands. We have 3,000 plus 1,000 is 4,000. Okay, so there's the area model. Now I'd like you to try one on your own, or with the person next to you, your table, whatever you want to do. I'll set it up for you. Here comes a rectangle. And let's say we make this one the multiplication problem of 32 times 73. Okay. So I want you on your own to do 32 by 73 using the area model. If you need to, you can jump back and see the previous 2 examples. You can talk together, but work on it yourselves. Now would be the time to pause the video to make sure that you don't see that, my explanation that follows. So hopefully you pause the video, and now we're going to see how you did. So now we're going to make this side, since it's longer, we'll make it 73. We'll break it up into 70 plus 3. This guy here, we will make 32. We'll break it into 30 plus 2. All right. First, we'll start with 2 times 3. That's an area of 6, so we got 6 little squares down there. We'll do 30 times 3. That's 90. We'll do, what do we have here? 70 by 2. That's 140. And we'll do 70 by 30. That's going to be 2100. So 2100 plus 90 plus 140 plus 6. So we add them all together, we get 6. Add the tens together, we get 130. So that's a 3 for the tens place, 1 for the hundreds. Add up the hundreds, we have 3 hundreds. And the thousands, we just have the 2000s, 2,336. So now we see why the multiplication algorithm is done the way that it is, why it makes sense, why we do each thing that we do, just by using this simple area model. And what I want you to understand is the reason that I'm having us do this area thing is that even in algebra, where it seems like we're maybe past these simple things of multiplication, we're not. We multiply things all the time. We multiply variables together. It makes sense of something called the distributive property, which some of you use, some of you haven't. Okay, it makes absolute sense of distribution. It makes sense of a thing called FOIL, if you've ever heard of FOIL, which it's kind of better if you haven't, because FOIL is just a way to remember an algorithm. I can find video after video for you on YouTube of people who love math railing against FOIL and how it just concentrates on memory and it does not concentrate on understanding. So anyway, this area model is very useful and versatile going into the future. Again, take it from me, somebody who knows math. It's worth taking the time to learn and to use. What I want you to do now is challenge yourself. Okay, I'm going to put up a couple of different multiplication problems